What is an earthquake? Earthquake is simply a sudden quake, a sudden tremor felt in the earth's surface is known as an earthquake. A sudden quake or a sudden tremor felt in the earth's surface is known as an earthquake. In other words, you can say vibrant release of energy. The vibrant release of energy is an earthquake. A sudden tremor or sudden shaking of the earth's surface, sudden tremor, sudden quake, sudden shaking of the earth's surface is known as an earthquake, right? Or in other words, it is vibrant release of energy is known as an earthquake, right? So the point of source of origin of an earthquake, it is known as focus. The point of source of origin of an earthquake, it is known as focus. And the point vertically lying above focus, it is known as an epicenter. It is known as an epicenter, right? It is known as an epicenter. There is shortest distance between focus and epicenter. Suppose this is our earth, right? Most of the earthquake focus of the world is found in crustal part. Crustal part, that is lithosphere. Lithos means rock, rockosphere or lithosphere. Since this is rocky layer, rocky strata, rocky surfaces, so there is maximum chances of breaking and rupture of the rock could take place only in the crustal part. So most of the earthquake focus are present in crustal part only. As you know, you are well aware about the interior of the earth. After focus, we will get what? Mantle. Mantle is semi-solid or semi-liquid condition. Then we will get the outer core completely liquid, and then inner core, it is in plasma state. So the only rocky strata, the only rocky surfaces we found in crustal part only. Lithos means what? Rock, rockosphere, lithosphere. So the maximum possibility of rupture and breaking and folding of the rock could take place only in the crustal part. There is shortest distance between focus and epicenter. So as you move away from the focus, here the distance gradually increasing. All right, world map, right? Suppose an earthquake occurred here, suppose in Turkey. An earthquake occurred here in Turkey, right? So after occurrence of an earthquake, first of all, what we will get? What we will notice? Focus or epicenter? So guys, as you know, epicenter, it lies on the top of the earth's surface. Just beneath the epicenter, we will get the focus, right? Focus is always located beneath the earth crust, right? So first of all, what we will get, my dear? We will notice the epicenter. So suppose this is epicenter in Turkey, right? From here, from epicenter, from Turkey, its maximum effect will be Iraq, then Iran, then Pakistan, then India, then Myanmar, then Philippines, and gradually the distance is increasing. In the same manner here, Greece, then France, then UK, then Atlantic Ocean, then North America. Here gradually distance is increasing. So in the same manner, guys, suppose this is Turkey, an epicenter. Just beneath the epicenter, we will get the focus. And suppose this is Iran, This is Afghanistan, India, Myanmar, Philippines, Pacific Ocean. The distance is what? Gradually increasing. From Turkey westward, we have Greece, then Italy, then UK, then Atlantic Ocean. The distance is gradually increasing, right? So, the earthquake waves originating from the focus, first of all, they will reach near the epicenter. Earthquake waves first originating from the focus, they will reach near the where? Epicenter. Since it is the shortest distance, right? So the earthquake waves originating from the focus will first strike near the epicenter. So what is the identification of an epicenter? How you will recognize, how you will distinct between this is an exact epicenter and this area is situated away from the epicenter? So how you will distinguish? Now let's see. Suppose this is our earth surface. Suppose this is our earth surface, right? Suppose this is our earth surface and this is focus. The area vertically lying above focus is epicenter. Here you have human settlement over here, right? Human settlements over here on the top of the earth surface. So earthquake waves originating from focus, they will first reach near the epicenter since it is the shortest distance. So these earthquake waves vertically striking beneath, these earthquake originating from the focus, they vertically striking beneath. So how this plane is moving? Up and down. So artifacts, objects, human settlement situated on the epicenter, they will move up and down. There will be up and down movement near the epicenter since the earthquake waves vertically striking beneath. Away from the epicenter, there will be to and fro motion. Away from the epicenter, the objects, the human settlement, they will move to and fro exactly near the epicenter, exactly at the epicenter. Since these earthquake waves are vertically striking beneath, that's why they will move the epicenter. The object situated near the epicenter, it will move up and down, right? So in a layman language, how you can distinguish, how you can identify an epicenter, right? So till now what we discussed, what is focus, the source of origin of an earthquake, it is known as focus, and the area and the point vertically located above focus, it is known as an epicenter. So next one is a scaling of an earthquake. A scaling of an earthquake. Scaling of an earthquake, right? So there are two ways, there are two methods by which we can scale, we can quantify an earthquake, right? So these two methods are, first one is intensity scale, and the second one is magnitude scale, right? So the first one is intensity scale and the second one is magnitude scale. All right. So intensity scale, it is based on human observation. The intensity scale is based on human observation. It is based on the empirical, it is kind of empirical method. It is based on the personal observation of the scholar. Intensity scale, it is more or less humanitarian in method. Humanitarian approach is there. It is more or less humanitarian in nature. based on the personal observation of the scholar, based on the personal observation of the scholar, or in other words, you can say it is empirical in nature. What do you mean by the term empirical? Empirical means what? Empirical means based on personal observation of the scholar, personal observation of the researcher. So intensity scale, it is based on human observation, based on the personal observation of the scholar. It is more or less humanitarian in approach, humanitarian in method. Intensity scale, the best example of an intensity scale is Torriso-Mercalli scale. Torriso-Mercalli scale. So just please look at the spelling Mercalli, Torriso-Mercalli. In the last page, someone written Anarcali scale. So guys, this is not Anarcali scale. This is Torriso-Mercalli. Mercalli. He was famous seismologist of Italy. He was an Italian earthquake scientist, Italian seismologist, Torriso-Mercalli. In 1952, he gave intensity scale. There are two kinds, there are two methods of measuring an earthquake, of scaling an earthquake. The first scale is intensity scale. It is empirical in nature, based on the personal observation of the scholar. Okay, it is humanitarian in approach, right? Torriso-Mercalli, he gave this scale in 1952, right? So what is the range of the Mercalli scale? It is 1 to 12. 1 to 12. Mercalli scale, its range lies between 1 to 12. As I told you, repeatedly told you, it is based on human observation. So simply it is a kind of charting. It is kind of charting method, right? Simply charting means what? Suppose an earthquake occurred somewhere on the earth surface, and in Mercalli scale it lies in 2. 2 means what? It is not felt by everyone. It is only felt by sensitive people. In range 5, window glasses are broken, car glasses are broken. In range 8, railway line bends. And in range 12, there is total catastrophic. Objects are thrown into the air, right? So like this manner, its range varies between 1 to 12, right? Next one is magnitude scale. So guys, what is magnitude actually? Magnitude. What is magnitude actually? Magnitude is what? Magnitude when energy aspect is added in it. Magnitude means intensity plus energy. Magnitude means what? Intensity plus energy, right? When energy aspect is also added to the vibration. In simple, very simple language, what is magnitude? Magnitude means frequency, vibration, that is intensity, as well as energy component, energy element, energy aspect is also added to it. And the best example of magnitude scale is, and the best example of magnitude scale is Richter scale. Richter scale in 1932. And the best example of magnitude scale is Richter scale 1932. So how Richter scale actually functions? Just try to understand, guys, how it works, Richter scale. What is the basic functioning of Richter scale? Usually in UPSC, this question is asked once or twice in your previous year paper. You can notice this question, how this Richter scale actually works. So first of all, suppose this is a scale, then we have energy released, and you are well aware energy is measured in what? Joule, and greater quantum of energy is measured in kilojoule. So energy, it is usually measured in kilojoule. And the third component is vibration. Vibration, right? So let's see. Let's see. As I told you, intensity scale, the best example is Mercalli scale. It range vary from 1 to 12, and the best example of magnitude scale is Richter scale, and its range varies from 0 to 9. 0 to 9. So how it actually functions? Suppose on Richter scale 1, on Richter scale 1, the energy released is 32.5 kilojoule and the vibration is 10. So in the next stage, in the next scale, that is 1.1 and 1.2, 1.3, 1.4, 1.5, 1.6, 1.9 and so on to, it is actually based on logarithmic table, right? Logarithmic function, actually it had 1.1. Suppose in Richter scale 1.1, the energy is 32.5 into 32.5 and the vibration is 10 into 10. In the next stage 1.2, the energy released is 32.5 into 32.5 into 32.5 and the vibration is 10 into 10. In 1.3, right? So 32.5 into 32.5 into 32.5 and the vibration is 10 into 10 into 10 and so on. It will go up to 9, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9 and then 2, 2.1, 2.2 and so on. It will reach up to, it will go up to 9. So this is the basic functioning of Richter scale. So guys, please comment in the comment section from scale 1 and here 1.3, 1 to 1.3, this vibration is how much? This vibration is how much, right? From 1 to 1.4. In every stage, what you are noticing here, in every stage, there is an increase of 32.5 fold increase in the energy. In every stage, there is 32.5 fold increase in the energy and vibration vibration increases by 10 times. So from first to 1.4, how much this is different? How much this is more? Bhavna, it is 4 times. No, Bhavna, sorry dear. So this one is 10. Anyone among you? Okay, please comment rapidly. So 10,000 times, Salman. Yes, well done, Salman. It is 10,000 times. So from 1 to 4, this is 10 times more. Then we have 10 into 10, 100 times more. And then it is 1,000 times more. Then we have 10,000 times. Then we have 1 lakh times in such a manner, right? So this is the basic functioning of Richter scale. Now, the main question is, how does an earthquake occur? What are the major causes of an earthquake? How does an earthquake occur? What are the major causes of an earthquake? The first cause of an occurrence of an earthquake is folding and faulting of the rocks, folding and faulting of the earth crust or rocks, folding and faulting of the earth crust or rocks. As you know, earth is continuously rotating on its axis. Due to this reason, a lot of vertical and horizontal forces are originated, right? So some of these forces act in the same direction, whereas some of these forces act in the opposite direction. When these two forces operating on the earth crust act in the same direction, this part of the earth surface will be folded, right? Folding takes place due to compressional forces. Folding is an outcome of, folding is the result of compressional forces, whereas faulting, faulting is due to the, faulting is the due to the tensional forces. Due to the tensional forces, faulting is the result of tensional forces, whereas folding is the result of compressional forces. Here forces are acting in the same direction, here forces are acting in the opposite direction. So the major cause of occurrence of an earthquake is folding and faulting of the rocks or earthquake. So it was best explained by H.F. Reed with the help of his elastic rebound theory. It was best explained by H.F. Reed with the help of elastic rebound theory. It was best explained by H.F. Reed with the help of his elastic rebound theory. Right? Now, let's try to understand what is elastic rebound theory actually. Suppose this is certain part of the earth surface, certain part of the earth crust. Here, this side of the earth crust, we have human settlement, right? This side, we have human settlement. Now, human being have constructed, suppose, dam over there, man-made reservoir or dam. The construction of man-made dam will result into the formation of a reservoir. Suppose this is reservoir, storage of water, reservoir formed over there. This reservoir will put hydrostatic pressure on this part of the earth crust. The construction of man-made dam across the river will result into the formation of a man-made reservoir, human-made reservoir, which will put hydrostatic pressure on this part of the earth surface. Now, what will happen? In due course of time, what will happen? In the next stage, here folding will take place. This part of the earth crust will be bended, will be folded like this manner. The point where an imaginary line or the point where folding of rock take place, this imaginary plane or an imaginary axis along which the folding take place, the imaginary axis along which the folding take place, it is known as fault line. It is known as what? Fault line. As you are well aware, here we have human settlement here. Now, human being have constructed what? Dam over there. This dam resulted into the formation of a reservoir, and this reservoir constantly adding, constantly putting pressure on this part of the rock. Now, what will happen in the next stage? This will be folded, and when the tensile strength will be greater, then in next stage, this part of the earth crust, this part of the rock will be broken. What will happen? So here, this is part of the earth crust, a part of the rock. This side, we have constructed dams, reservoir, human settlement here, and this part of the crust, we have constructed human reservoir over here. So what will happen? So what will happen? This part of the rock will be broken and it will slide. It will be pulled under the influence of gravity also. It will be pulled, right? So as soon as this part of the rock is broken, it is this rock, it has certain mass also. It is possessing certain mass. and it has certain velocity also. So P is equal to mv square. This broken part, as soon as it will be broken, it will move down under the influence of gravity. Under the influence of gravity, it will have certain velocity also. So what will happen? Newton's third law will be applicable here. What will happen? This broken part of the rock, as soon as it slides down, as soon as it is broken down under the influence of gravity, it moves below, but it has certain velocity, it has certain mass. So Newton's third law will be applicable here. There is equal and opposite action. There is equal and opposite reaction. You are well aware about the Newton's third law. There is equal and what? Anyone? Can you comment, guys? There is equal and opposite reaction. Okay. So this broken part of the rock, it will once again, it will jump. Okay. It will try to regain its lost position. It will try to regain its original position. This broken part of the rock, it will try to regain its lost position. This broken part of the rock, it will try to regain its lost position. In this process, the sudden shaking of the earth will take place. The sudden shaking here, the sudden shaking of the earth will take place. This is what? Focus. And here, these are the earthquake waves. Now, you can make this diagram in three-dimensional manner also. So this is what? Three-dimensional manner also. You can make this diagram also here, right? So this is how an earthquake occurs. So this part is what? This part is what? So this part is epicenter, and the point where the source of origin of an earthquake take place. This is focus and this is epicenter. Epicenter vertically lying above. So equal and opposite reaction, of course. Okay. So this is how an earthquake occurs according to whom? H.F. Reid, elastic rebound theory of H.F. Reid. Now, the next cause of an earthquake is plate movement. The next cause of an earthquake is plate movement. Plate movement. Plate movement. There are primarily three kinds of plate movement. The first one, when two plates move opposite to each other. In this condition, certain displacement of the mass, certain displacement of the rock is taking place. This displacement results into the sudden shaking of the earth's surface. Second kind of plate movement is when two plates collide with each other. Second kind of plate movement is when two plates collide with each other. And the third one is here when two plates move parallel to each other. We are well aware in plate movement is also the major cause of occurrence of an earthquake world over. The first cause I told you, due to folding and faulting of the rocks, and it was best explained by whom? H.F. Reid with the help of elastic rebound theory. According to this theory, rocks possesses certain kind of elasticity. This broken part of the rock try to regain its lost position, try to regain its original position. In this case, earthquake occur. In this condition, an earthquake occur. But plate movement, what is plate movement? Earth crust is broken into numerous plates, and there are total 26 plates on the earth surface, out of which 7 are major plates and 19 are minor plates. These plates, some of these plates are moving in the opposite direction, some of the plates are moving in the same direction, whereas some plates are moving parallel to each other. This plate movement result into the occurrence of an earthquake.